Let's skip to the next speaker. Valter Maggi, I suppose he is online.
Did you hear me?
Are you in the Zoom, Valter? Okay, the floor is yours.
Okay, did you hear me?
Yes, Valter, we can.
Okay, I try to.
We are a bit late, Valter, so please stay in the time.
Okay, did you see the presentation?
Yes, we do.
Okay, thank you very much. Yeah, we know very well which is the importance of glaciers, and Maurizio in the beginning explained well the capacity of monitor of the climate change of the glacier. But the glacier have another important function, and is the glacier collects information about climate and environmental events that we have, for example, around Europe. Oh, sorry, I made some mistake. I don't know what happened. And sorry, I try this one. Okay, I want to show laser. Okay, so what we have?
Okay, yes, skip the panel with subtitles. I think you have to click on the OK.
If I can, I try. I don't know. Okay.
Okay,
sorry,
that's fine.
Very sorry again. What to say that the importance of glacier as a storage of climatic and environmental information, and normally possible to use information using, for example, ice core systems that provide a long range of this information that you can interpret as different kind of record, and use for compare, for example, with a modeling system that can help in the interpretation of this data. Clearly, the problem that we how glaciers are in strong retreat and long problem in the mass balance reducing, clearly strongly related not only to but also situational example that is another important parameter that work against the glacier today. And clearly the next future of the glacier seem to be not so good, because all the modeling show the of the mass balance of the mass of the glacier mass in the next century, and the end of this century. And if we check for the European Alps, in this scenario, we have probably the disappear of the maximum part of the glacier. So what we have to do is try to understand well which is the possible future of the glacier, and this is the same for most of the glacier areas that we most are in the north. The reduction is less, but if you go in the mid-latitude areas, clearly the situation is very critical. Clearly, the Alps represent one of this important area. the glaciers. We are in the middle latitude, so the glacier normally are in danger. I want to remind you that 90% of the glaciers on the Alps is temperature glacier, and the glacier, a glacier with ice very close to the melting point, and this is the reason some of them are in a strong retreat. If you do try to estimate the situation of the glacier, we can show the position of the area where the temperature is very low for the alpine sense of view, obviously, and the altitude very high, but the maximum part of the glacier is related around this area. So what happened is very clear. The point, the altitude are much high, and on the glacier, called the list, called the Ninfetti bank, represent area where the situation is a bit better. Clearly, also these glaciers are in retreat. But this is the problem that we have. I want to use the glacier as archive of climate and environmental information. It is clear that the better are the cold or polythermal, like that, but we have a lot of information stored inside of this glacier, and for recovery we need to work very fast. I can show you one example. One example is the Adamello Glacier. Adamello Glacier located the southern part of the Central Alps, and you see these two circles. The red circle is around 1 kilometer far from the glacier, and the yellow one is 200 kilometers from the glacier. And it is clear that you see in the 200 kilometers from the glacier, we close practically one of the most industrialized area of the Europe, also clearly in Germany, Switzerland and Germany too. And the reason because this glacier become very important and collect all the information that we have in the atmosphere and reaching the center of Alps. The Adamello Glacier is the Adamello Glacier. We drill sometimes in the accumulation area, and we made also some radio echo sounding and some geophysical. This is the view, the frontal view of the glacier, and this is the Neve. The surface of the glacier is at least 15 square kilometer. Is the largest Italian glacier, so it's not the largest of Europe, but it's the largest of Italy. The accumulation basin is located at least 3,200 meters above the sea level, and the mean annual temperature of Pian di Neve, we don't know any weather station here, but we made some calculation from two stations close around Passo della Lobby, close back this mountain, and Careserli Dam in the valley, in this part, and if we try to calculate the lapse rate, we estimate the temperature between -4 and -6 degrees mean annual temperature. So the mean annual temperature is very close to zero, and that means that clearly this glacier is in strong reduction. In effect, if we see the mass balance, it's in Italian, but it's a winter balance, the summer mass balance, and in green is the net balance. This is the balance accumulated, so the sum of all the data. What is it's clear that there is a continuous decrease of the ice in the glacier. Okay, we have 2 years in very positive, but was a small increase in the middle of this dramatic retreat. And this glacier is also the deeper of Italy. In 2016, we estimate 270 meter depth, and this is a surprise also for us. But what is fantastic is that from 2008 to today, we lose around 12 meters of surface. So what happened is that the glacier is not a retreat only in terms of surface or in from the front, but they have also a decrease on the altitude. This is the rather geophysical profile inside of the glacier. Around is the Pian di Neve. This is the depth, 270 meter depth of ice, and we reach one more in the basal moraine, and this is sediments. So this is what is the drilling that we done in this spring. So we had also another drill made very close here, and this drill made only 40 meter. This 40 meter we are able to work in the for study many parameters. Some we have study, an example, the level, the horizon, the level of horizon inside of the glacier, and we found the one Zoom peak dated 1963 that represent the finish the ban of the atmospheric bomb test in 62, and the Chernobyl peak in 1986. We had also a possibility to make some pollen record analysis where it's possible to see some annual layers inside, and we done also the LED 110 for dating this ice. So from the surface to 40 meter depth, we had the possibility to build up a kind of age relationship. The problem is that when we finish to date, we reach the surface. This part of the fresh snow on the surface, so it's not possible to collect very well, but it's only few meters.
Walter, can you move to the conclusions? We are very late.
So what happened is that we lose 25 years of this glacier. So what means that the surface that we have is in the middle of 19th year. So what happened is that we lose every year we lose information from the glacier. So which is the key message? The key message is that we have a kind of race. In the last 70 years, okay, we can use 120 or 150, but in the last 70 years, we have seeing a kind of race between climate change and glacier, and climate change claim winning today. So what we need is collect as fast as possible the glacier for the future studies, because if not, we lose every year a lot of information. And this is exactly my message that I want to send to you, and hope is help for the next work. Thank you very much.